In this paper, we introduced 3 gesture sets designed with interaction designers and evaluated how gesture design affects embodiment and task performance. We explored how to enhance the sense of embodiment through active control and proposed a methodology for designing, evaluating, and implementing a control method for user-driven body deformation. We engaged 6 designers to create gesture sets for forearm control. The design criteria were simplicity and natural motion. After designer evaluations, we selected the top 3 sets for implementation. Our setup includes 6 OptiTrack cameras and 5 markers on each user's hand and forearm. To activate or deactivate the gesture set, users must clench all fingers except the thumb raised and wiggle side to side twice. To activate the state of the forearm elongating, users must raise the thumb away from the index finger. To activate the state of the forearm shortening, users must move the thumb toward the little finger to gradually shorten the forearm. To activate the state of the forearm bending, users must rotate the wrist to bend the forearm in the fist's pointing direction. Set B's gesture set consists of 2 main steps to activate, the first of which is to grasp the fist and then open it. To activate the state of the forearm elongating, users must move the forearm away from the body with the first step. The user's forearm will gradually elongate when they move their hand away from the body. To activate the state of the forearm shortening, users must move the forearm towards the body with the first step. The user's forearm will gradually shorten when they move their hand towards the body. To activate the state of the forearm bending, they must rotate the wrist with the first step. The degree of bending correlates with the degree of finger spread. The deactivate gesture is grasping the fist. Set C gesture set has no specific activation action. To forearm elongating, users must curl the middle, ring, and little fingers, keeping the index and thumb parallel to the middle finger's plane. To forearm shortening, users must curl their middle, ring, and tail fingers, and adjust the thumb and index to form a perpendicular angle to the index finger's plane. To forearm bending, it is similar to elongating, but with the index finger pointing away from the forearm's extension direction. We evaluated these gesture sets with 18 participants, focusing on embodiment, cognitive load, and task efficiency. Participants used the gestures to interact with virtual balls that appeared randomly, aiming to click them as quickly as possible. To showcase our gesture set, we developed 3 VR scenarios.